Good morning. This morning we are doing the Exam 2 preparation, the citations, the lookalike problems from the text, the e-text. So let's go ahead and get started. This is M111 Exam 2 prep. Okay, on problem number 1, you need to have the distance formula. Okay. With the distance formula, I'll give you 2 points and then you tell me the length between them. The citation is page 173, problems 11 through 18. Problem number 2, you need to know the formula for the midpoints, the x and y values for the midpoint of a segment. I give you 2 points and you find the midpoint between those 2 points. Page 173, also number 11 through 18. Problem number 3 is the same citation as number 2, and it's also a midpoint problem. Problem number 4. On number 4, I give you an equation for a circle, and you have to find the center and the radius of the circle. The citation is page 181, problems 1 through 26. Number 5 is also a circle problem. This time I give you the center and I give you the radius, and you have to write the general equation for that circle. Problem number 6. I give you several sets of points, and you have to list for me the domain and the range, and if it is a function or if it is not a function. The citation is page 184, examples 1 and 2. Problem number 7. I give you a graph. You have to tell me whether this graph defines a function of x. Basically, I expect you to use the vertical line test and explain why. Okay, page 185, example 3. Problem number 6. I give you a function and you have to evaluate it. For example, I might give you f of 6 and you have to evaluate using the 6. Page 187, example 5. Problem number 9. Also an evaluation where you have to evaluate for a different expression. Page 187, example 6. Number 10. I give you a linear equation in standard form. You have to find the x-intercept and the y-intercepts, and you also have to graph the line. I give you the graph paper. Page 188, example 6 and example 7. Problem number 11. I give you a graph. You have to tell me the domain and the range. In other words, the span of possible x values and the span of possible y values. There is no citation for this particular problem. Problem number 12. The line passes through a point and has a given slope. You have to use the point slope formula, and the The citation on that is my handout on slope equations. Problem number 13. You must use the point slope formula to write the equation of a line and give it in slope intercept form. I give you 2 points. So this is a 2-step problem. First, you have to find the slope. Then you use one of the points and the slope in the point slope formula to get the equation. Again, the citation is my handout on slope intercept type equations. Number 14, I give you an equation in slope intercept form. I give you 2 of them actually, and you have to tell me if these 2 equations are parallel, perpendicular, or neither. If you recall, to be parallel, they must have the same slope. To be perpendicular, they must have the opposite reciprocal slope. The citation, again, my handout. Number 15, I give you a point and I tell you that that point is parallel to a line that happens to be in standard form. First, you need to convert that standard form to slope intercept form. In other words, isolate the y and then find the slope. Then you use the point slope problem formula and use the point given, and you use the slope given since it's parallel or computed, and you get the equation of the new line. Once again, the citation is my handout. Number 16, I give you a point. I give you an equation in standard form. You have to find the line perpendicular to it. So you change the standard form to slope intercept form, find the slope of the original equation. Then you take the opposite reciprocal slope with the point slope formula to find the equation. The citation, my handout. Number 17, you have to find, I give you a point and you have to find the point that is symmetric with respect to the x-axis. That's page 255, problems 1 through 3. Number 18, I give you the equation of a quadrilateral. You have to tell whether the graph is respect to the x-axis, the y-axis, and the origin. Page 255, number 1 through 3, also number 7 through 11. Number 19, you tell whether a function is odd, even, or neither. The citation is page 255, number 19 through 20, and page 256, number 27 through 32. Number 20, is a transformation problem. I give you an equation and you have to tell me, like, does it shift left, right, up, down, rotate, mirror across the X or Y axis? You have to tell me what changes are affected. Number 21 is a similar problem. Number 20 and 21, the citations are page 236, the table, page 237, example 7, and page 239, problems 1 through 8, and then number 18. Number 21. Is another transformation problem. You have to tell me whether something shifts left, right, up, down, or whether it's flipped across an axis. Page 239, problems 1 through 3. Problem 23. I give you a piece of graph paper. I give you an equation. Okay. You have to find the transformed graph. Page 239, number 1 through 3, and number 15 through 26. This one happens to be multiple choice, and I show you the original equation, the graph of the original equation, y equal x squared. Okay, number 24. I give you 3 functions, and I give you 3 graphs, and you have to identify which graph goes with which function. The citation, the front cover of your book, page 239, or 229 rather, table 2-2, or my handout showing the basic function graphs. Number 25. I give you a theoretical function, and you have to tell me whether this would be a vertical or horizontal, up or down, left or right shift. Page 239, number 1 through 8. Okay, problem number 26. You will be determining whether it's vertical stretch, vertical shrink, horizontal stretch, or horizontal shrink of a graph. Page 239, number 1 through 8. Number 27. Number 27 is similar to number 24. I give you 3 graphs, and I give you 3 functions, and you have to tell which graph goes with which function. The citation is 229, table 2-2, also my handout that has the function graphs on. Number 28, I give you a function, and you have to tell me you have to determine what the correct function, this one's multiple choice, is based on the transformations in the equation. The citation is to page 238, number 7, page 242, number 96. Problem number 29. I give you the graph of a function. You have to tell me whether it is what intervals it is increasing, decreasing, or constant. The citation on that is page 258, 259, problems 91 through 96. Problem number 30, I give you a piecewise graph. Page 257, 258, number 62 through 71. Number 31, I give you a composite graph, and you have to tell me what are relative maximas and what are relative minimas. Number 32. Oh, the citation on 31 is page 258, number 89 through 90. Number 32, I give you function notation, and you have to tell me whether that indicates a reflection across the X or Y axis. Page 236, transformation of functions table, number 8, problem number 8, and also page 240, number 41 through 54. And that's the problems on the test. You've seen the kind of things, there are transformations on it. There are certainly slope intercept problems on it. Distance, midpoint, circle. Those are the primary areas that are covered on this test. There is a little bit on symmetry right at the end, which is covered the last day of class before the test. With that, good luck on the test.